Yeah. Okay, thank you. The work I'm going to be presenting this morning is lessons learned of the SEREINE project applied to housing blocks. So you might know the SEREINE measurement method. So it aims at measuring the HTC without occupants. Initially we developed it for houses. For houses, it's very simple. We gently ask the occupants to leave their homes for the weekend so that we can perfectly control the indoor environment. We bring these little portable heaters. We optimize the thermal solicitation of the envelope by following this little on and off pattern, heating pattern. And that works within 1 or 2 days. And one of the questions we had is this transferable to collective housing? So bigger buildings, lots of units. We had this question because, in particular, social housing stakeholders are interested. They spend maybe thousands, hundreds of thousands of euros retrofitting their homes, so they want to have a measurement method to guarantee that they reach performance. So the first thing is, developing such a method is to think, can we this time gently ask the occupants to leave the building? The answer is not. Not only because it's operationally very difficult, but also because when you have occupants, your heat balance is led by heat transfer through transmission, infiltration, ventilation, and heat and solar gains. And the thing is, if we want to be able to make a guarantee, an energy guarantee on the performance, you need to be able to confront it to what has been calculated. And in the French regulation context, but you can't have the heat transfer through ventilation or solar gains if you want to compare it properly. So this means that we had in any case, to work without occupants and to shut the ventilation down so that we can only focus on transmission and infiltration heat transfer. But then a new question, how on earth can we control the entire environment of the housing block? First of all, homogeneous control over the entire building is practically infeasible. And in any case, it's from an operational point of view, it's unthinkable. We can't have occupants out, and even when they do the works or the retrofit operations without the occupants, or when it's a newly built building, having the building for 1 week or 2 is absolutely unthinkable. We have all the time people over, and you can't just shut all the doors. So the solution we found is to sample the apartments. 1 unit is pretty much like a house, so that volume we can control. But then we had 2 questions. If we sample it, what to do with the heat flux to and from the neighbors? We can't just apply the on and off pattern we used to apply in detached housing. We need to adapt our heating pattern to the particularity of building units. And then how to scale up the results. You have 1, 2, 3, maybe 4 development measurements, but then you need to be able to say this is representative of your entire building. So spoiler alert, it's not really. So these next few slides are the lessons learned of what we have been trying to do over the past 3 years. There's still a lot to do, so it's sort of an appetizer. And if you'd like to know more, please reach out. First lessons learned is about apartment testing. How do you have an HTC measurement of an apartment that's reliable and trustworthy? As I said, your first threat here is actually having a lot of heat flux to and from the neighbors. When your building is not retrofitted, your heat balance is not driven in majority by these heat transfers. But in this case, we would actually want the measurement to be used after retrofits. So this means that the envelope towards the walls is well retrofitted. Your thermal resistance is very high, but the party walls that they've not been treated. And so in the end, your heat balance is very, very largely affected by these heat transfer. So we've done a little calculation for even for a corner unit. So you'd be, I don't know, the upper level on the corner. So you'd have a lot of, well, you maximize your envelope towards the outdoors. But even then, when you have a 1 degree difference with your neighbors, when the building is retrofitted and when it's 0 degrees outside, transfers to and from the neighbors, it's half of the energy. So you can imagine that it influences your uncertainty on the measurement, because it's not something that you can easily measure. So seeing that even for a corner unit, it has such an influence, heat flux to and from the neighbors has such an influence, it means two things. It means that we cannot measure apartment units in the middle levels. We have to measure corner units, either on the upper floor or on the lower floor. And then we had to adjust the temperature set points. And suppose stationarity, we have to minimize the transfer to and from the neighbors. And to do that, we had to set the temperature set point at 20 degrees, hoping that in the neighboring zone it would be approximately the same, so that maybe we can reach, would minimize these heat transfers. When we did that, well, we still need to have an idea of how much how large these heat transfers are. So we, assessed two options. Either we have a temperature sensors at the neighbors in the neighboring zones, and then it means that we have to propose a U value for that multiple, because you can't always measure it. Or we place heat flux plates in the apartments that we're measuring. So it was kind of easier to do in the end, because very often we could just access the neighboring apartments. And we also noticed that the effect on uncertainty was lower when we used heat flux plates to measure this neighboring heat transfer. But the thing is, even when you do that, I mean, even when you place a lot of heat flux plates, you have, you can't go past some heterogeneity of the walls. The heat flux is not exactly the same anywhere on the walls. And so we did a lot of experimental, numerical experiments to see the effect of this spatial heterogeneity on the uncertainty of the HTC measurement of the apartments. And so when you have a very low heterogeneity, the uncertainty remains bounded and remains acceptable. And we can have a measurement that's trustworthy in winter and in shoulder season. But as soon as the heterogeneity grows, from the upper boundary chart was 5 watt per square meter, and we'd have an uncertainty so large that it would just measure would mean nothing. And
2 minutes.
2 minutes. Okay, well, I'll continue then. What we did is try then to assess what kind of heterogeneity do we encounter in the buildings. So it's in France, majority of concrete party walls. And what we noticed is that the 0.5, so the optimal case, 0.5 was actually never accounted. Most of the time we had something like plus or minus 2 watts per square meter in heterogeneity. So that's not even accounting for the uncertainty of the sensors. It's just that we assume that there's spatial heterogeneity. So this means that back here, we're actually most of the time here in this scenario. So the measurement can only be applied in strict winter to have something trustworthy and reliable at apartment scale. And then, assuming you have 1, 2, 3, maybe 4 apartments HTC that you've then performed in winter, how can we say this is representative of the entire envelope? I just said we can only measure corner units. So this means that it's very representative. If you have like a tower, you'd have lots of vertical walls. And if you only measure the corner units, well, they do not represent the vertical walls. And the thing is, when you only measure, I don't know, 2 or 3 apartments, and your building has 20, it's definitely not representative. And in addition, you can't even actually solve the problem. You want the HTC of the entire building. You only have the HTC of 2, 3, or 4 units. I mean, though, mathematically, it doesn't work. So the trick was to use a Bayesian approach to regularize the systems. I will not go into detail. Works. HTC is a bit, well, it's not perfectly identifiable. So we turned it into so not an HTC upscaling, but a counter-performance risk indicator. So as soon as you have enough apartments measured, so we noticed that at least 3 apartments is absolutely necessary. When you have that, then you can say with certainty that you can reject or accept with kind of certainty performance hypothesis as was intended. So back to square one, we wanted to measure the HTC of housing blocks. In the end, we haven't actually quite succeeded because we can measure the HTC of each apartment separately, of corner units separately, okay, but we were not able to actually have the HTC of the entire building. So the funders were okay with that answer. But we were not, because we were still a bit frustrated. And so, well, plan B maybe would be to actually leave the occupants in and just go towards, in-use HTC measurements, which might, in the end, maybe be as good as the solution we found. And that would be it.
Okay, thank you, Sarah. Is it finished? Okay. Oh, 2 minutes old. Right. So time we have lunch now?
I think, yeah, let's have some lunch.
So for those online, you go and get your lunch.